Welcome to my video on square roots. So, a perfect square is a whole number. So think 16, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and 7 times 7 is 49, etc., whose square root is an integer. An integer, think -4 and 4 because they're opposites, or -7 and the opposite would be +7. Okay, so square root is a factor of a perfect square. So the symbol is this, and we call that a radical. So to determine if the whole number you have is a perfect square, type in the number inside the square root symbol. So whatever number is inside the square root symbol, so for example, we would type in 169, and then we would hit the square root button. If you get an integer, it's a perfect square. If you get a decimal, then it's not a perfect square, and we would call that an irrational number with an I. So let's look at some practice here. So it says find each square root, determine if each is a perfect square. So the square root of 49 would be 7 because 7 times 7 is 49. The square root of 25 is 5 because 5 times 5 is 25. The square root of 0 is 0 because 0 times 0 is 0. And now the square root of 50. Now 50 is not a perfect square, so if we typed it in, our calculator would say 7.07, and we would write ... showing that it goes on and on forever and ever. The square root of 14 would be 3.74 ... And finally, the square root of 2 would be 1.41 ... And the ... shows that it goes on and on forever. But it is not repeating, so I did not use a repeating symbol. So, which numbers are perfect squares? We would say 49, 25, and 0 are perfect squares because their square root is an integer. Now 50, 14, and 2 are not perfect squares because their square root is a decimal. Okay, it says find each square root. Determine if each below is a perfect square. Now you'll notice these are the same as the ones above. However, the difference is there's a negative in front. So we are going to see what that negative does. So I would type in the square root of 49, and the square root of 49 is 7. But there's a negative in front, so we would call this -7. And remember, -7 times -7 is 49. Okay, the next one, because 5 times 5 is 25, we would say 5, but there's a negative in front, so we would call this -5. And then the square root of 0 is 0. Now this time there's a negative in front, but we still say it's 0. Remember, 0 is neutral, it's not negative, it's not positive. Okay, the square root of 50, remember, was 7.07 dot, dot, dot. But remember, the negative sign makes it negative, so put the negative in front. Square root of 14, remember from above was 3.74, dot, dot, dot. Put the negative in front. And the last one was 1.41, dot, dot, dot. And remember to put the negative back in front. So we say that 49, once again, 25, and 0 are perfect squares because their square root is an integer. Okay, now we are going to look at the next part, which says which ones are not perfect squares. So we would say 50, 14, and 2 are not perfect squares because their square root is a decimal. Okay, now we're going to be looking at irrational numbers, and I mentioned this below. When the square root wasn't a perfect square, then we would call that irrational numbers. So now we're going to define that a little bit more clearly. So irrational numbers aren't perfect squares. Okay, irrational numbers are decimals where the digits don't repeat and never end. So these are called non-terminating, meaning they never stop. Terminate means to stop, so if they're non-terminating, they never stop. So we're going to follow the same steps and plot your solution between the two consecutive integers on a number line. Consecutive means one after another. So the first one is the square root of 34. So I would type in 34, hit the square root button, and my calculator says 5.83, and I would go dot, 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 meaning it goes on and on forever. So 5.83 would be between 5 and 6, so those are the consecutive numbers it would be between, and it's close to 6 but not quite. And I'm going to put the square root of 34 over the top of that. The next one is the square root of 70, so once again I would type in 70, hit the square root button, and it would be 8.36, dot, 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 showing that it goes on and on forever. Now this would be between 8 and 9, but a little bit closer to 8, but not quite halfway. We're going to call that the square root of 70. And then finally, the square root of 5, so I would hit 5 and then the square root button, and it's 2.23, dot, dot, dot. And that would be closer to 2 than it would be 3. And we're going to call that the square root of 5. So now it says the square root of 34 is between what two consecutive numbers? So I would look to where I put it, and it's between 5 and 6. The square root of 70, look where I put it, between 8 and 9. And finally, the last one, the square root of 5, is between 2 and 3. So I can fill that out between 2 and 3. Okay, let's look at the last section, and it says square root equations. It says you may find the square root of a number to determine the value of x. Because remember, the opposite of squaring something would be square root. So if I want to find the value of x and I see x squared, I can take the square root of this. And the reason I can do that is because x times x is x squared. So the square root of x squared would just be x. But remember, what I do to one side, I must do to the other. So x would equal 6. Now remember, 6 times 6 is 36. But there's another number that I can multiply together to get 36. So, or I could say negative 6 times negative 6. Okay, so go ahead and block that in. Okay, the next one, x squared equals 64. So the opposite of squaring something would be square root. What I do to one side, I must do to the other. So here, x would equal 8. Or 8 times 8 is 64, but also negative 8 times negative 8 would be 64. So I put or negative 8. Now, I'm going to show you a shortcut for this one. There's another way you'll see these two integers written. So let's look at this one. The opposite of x squared would be taking the square root. Square root of x squared is x, and the square root of 169 is 13. But remember, it can be positive 13 or negative 13, so here's our shortcut. We could say positive and negative 13. So that's just another way to represent the answer, and a shorter way to represent it. Okay, and finally, the last one, the square root of x squared. What I do to one side, I must do to the other. So x would equal 17. And remember, it can be positive 17 or negative 17. Okay, and the final section. If the value of a square root is irrational, with an I, then simply write your answers in square root form. So let's look here. The square root of x squared. What I do to one side, I must do to the other. So, if I type in the square root, 10, and then hit the square root button, I get 3.16 ... So, since it's an irrational because it doesn't repeat and it doesn't stop, we're going to write our answer in square root form. So the square root of x squared is x, and we're going to write the square root of 10. But remember, it can be positive square root of 10 or negative square root of 10. And box that in. Now look at the next example. X squared equals 5. So we're going to take the square root. What I do to one side, I must do to the other. And I type in 5, and I get 2.23 ... So it's not a perfect square. So we're going to write it in radical or square root form. So x equals the square root of 5 or negative square root of 5. Okay, now for these last two, we're going to write the shortcut. So opposite of x squared is square root. So what I do to one side, I must do to the other. 18 is not a perfect square, so I would type it in and get 4.24 ... So we're going to write our answer in square root form. So x equals square root of 18. But remember, it can be positive or negative. And box it in. And finally, the last one, opposite of x squared is square root. What I do to one side, I must do to the other. So x equals the square root of 120. And remember, it can be positive or negative. And box that in. Okay, that concludes our notes on square roots. I hope you have a great day.